Alright, so example number 2. So given the following sets, and well, these sets this time are not given as list of numbers, like the ones in example number 1. They're given as inequalities, and those inequalities represent certain sets of values, like for example, a set A. X such that x is greater than or equal to -4. That is, all the numbers that are greater than or equal -4, like -3, -2, -1, 0, 1, 2, 3, etc. Set B, on the other hand, looks a little bit different. It's all the numbers x that are less than 1. We're going to shade them accordingly. And last but not least, letter C, or set C, which is x greater than 2 in this case. All the numbers greater than 2. And again, notice the inequality symbols right here, the inequality signs. Some of them, well, one of them has the equal, that means includes the value -4, but the other two, the 1 and the 2, are going to be excluded from those sets because we only have the less than or the greater than. We don't have, unfortunately, that's a 1. We don't have this equal part that makes them equal. Okay, so let's see. So looking at letter A, they're asking us to find the union. Notice the union between B and C. That is, all the elements that add up together without repeating any duplicates or any overlaps like we did in the previous example. We just wrote the list of all the numbers, or the names example, the list of all the names without duplicating. So this is what we do. So I'm gonna go, let me label this our set B, our set C, and this is B union with C. All right? So we're going to look at the two sets individually. And well, let me use, okay, so here is the thing. I was expecting to get a nice blending of colors here. So, okay. So B, which is x less than 1, I'm going to go to 1, and I'm going to put parentheses here, and I'm going to shade this using, I'm going to use blue. Well, let me try another set of colors. Hopefully this works. Not quite. I think this is better. That's better, finally. Okay, so I'm going to use blue to shade the second set, that is x less than 1. I'm going to shade, so here we have two options. We have a couple of options. I'm going to go to -1. I'm going to either shade to the right or to the left. Well, in this case, all the numbers that are less than 1 are to the left. Actually, the inequality symbol is going to give us a sense of direction as to where to shade. In this case, well, you can think of this inequality symbol as an arrow pointing towards the left, and that's what I'm going to do. I'm going to shade all to the left. Make it a little bigger. Okay, like this. All right. So, and well, in this case, this parenthesis right here, it's indicating that we are not including the 1 itself. We're excluding the 1. All right. So that's set B. All right. Let me highlight it with blue just to color code. Let me use, oh no, never mind, because I need to do this pairwise. Never mind. Okay. So letter C, set C in this case. So what we're going to do is, I'm going to go to the number 2. All right? I'm going to go to the number 2, and then from here, I'm going to determine where to shade. So do we shade to the right of 2, or do we shade to the left of 2? What do you think for this one? Right. To the right, right? This is like an arrow indicating to the right. And in this case, I will also use parentheses to exclude the 2. That's because we don't have the equal. So, oops. And that's going to go all the way. All right, it's going to go all the way forever to positive infinity. Alright, so this is what we're going to do. We are going to do like a sandwich with these two sets. That is, well, put them together on one single line. So what I wish I could do, for example, is copy this one, put it together. But what I'm going to do is put those two together here in the third number line. That's going to look like this. So essentially, drop this shading in blue to the last one, to the third number line, and whoops, like this, all right? And then we will describe these two sets as a union. Okay, how are we going to do that? Well, notice we are looking for a union, not an intersection. In fact, if we were looking for the intersection, do you see any intersection? Do you see any overlap? Well, there's no overlap. Well, we're going to look at that case later. All right, so in this case, the union B union with C, all we do is simply describe these two individually as intervals. Again, this arrow pointing to the left indicates that we are coming from negative infinity and stopping at 1. However, excluding the 1, how do we show that exclusion? Well, with a 1 with parentheses, union, and then let's write the second interval, which starts now from 2 all the way. No, it doesn't stop at 8. Again, that's why I drew this arrow there, so you can see, so you can have a sense of something that never ends here. So that's going to be from 2 to infinity. All right? Question? A good question. That's because these two sets, B and C, here we have just the less than, and here we also have the less than. We would have had the bracket if we had the equal part right here. But because in this case we don't have the equal part, we just use parentheses. However, set A, do you see how we have the greater than or equal? That will involve a bracket, and I believe that's the case for the next one. That's the case. So let's sort of repeat the idea. I'm going to do one at a time. So, and again, for letter B, again, we have 3 blank number lines. And for each number line in the first one, on the first one, I'm going to shade set A this time, set B. On the second one,
Wait, so for the question before, are we still putting the parentheses on the number line, or are we putting an open circle on the number line?
That's a good question. Either one works. Sometimes some textbooks use the open circle instead of the parentheses. So these two are interchangeable. So it could be either way. So in this case, let's see. So the third number line will be for the overlaps, the intersection. Now, set A, in this case, from the top of the page, well, let me scroll to the top of the page. Okay, it's all the numbers that are greater than or equal to -4. So this is what I'm going to do. I'm going to locate the number -4 on the number line, which is going to be here. And then from there, we will decide whether to shade to the left or to the right. Which one is going to be this time? To the right, because it's greater than. All right? However, instead of parentheses like we did before, we're going to use bracket. Right? We're going to use brackets because this set A, right here, has the greater than or equal. Okay? Now, set B. Okay, set B, let me scroll up again. It's all the numbers that are less than 1. Again, I'm going to go to the number 1 on the number line. And then from there, well, it seems like we have to shade to the left again, all right? It's the same one from before. And with parentheses. And I'm going to use a different color here. Nope, not this one. All right. And, okay. Put an arrow to indicate goes forever. Put another arrow to indicate that it goes forever as well. All right, so this time check what we're going to do. In the same way with that we did before, I'm going to draw these two shadings again in the one same, but in this time in one same number line. That is, okay, let me repeat this. So it's going to be -1, +4, all right? Okay, I'm going to go to -1 with red. That means we have to go to the left, right? And in blue for the one that goes to the right, starting at -4. Now, in this case, notice the symbol. Check this out. We're looking for, whoops, this symbol right here means intersection. Or the overlaps. All right, it's the overlaps this time. And unfortunately, it's a little bit hard to see the overlap in here. Well, the way I did it in the past using a different software. I remember, I think I was using OneNote from Microsoft. It allowed me to do better colors or even markers. Well, here I have my notes with using markers. Usually I explain this in terms of some sort of color theory. Not that you are expected to know color theory, but I think it's one very common idea. It's that when we combine red with a blue, the result should be a shade of purple, right? So here, because we're looking only at the intersection, we're looking at the interval where the two together become purple. And what is that interval? How do we describe it with numbers? -4 to 1, all right? So in this case, -4 to 1, bracket for -4, and parentheses for 1. All right, let me make some space because I need to say A intersection B will be -4 to 1. So that's where the two are overlapping. So in the intersection, we only look for the overlaps. All right? Do you see the difference between the two? How in the previous example we were just putting them together, all together, whether they are in one or both, or in one the other or both. And we can also do not just 2 sets, but even 3 sets or 4 sets. However, for this class, we're going to keep it simple. And for this review idea, we're going to keep it with just 2 sets at a time. Question?
So when shading it on the graph, do you actually shade the whole thing, or only between -4 and 1?
So what I did, okay, yeah. So what I did is put this one in blue on the same, and we see that there's a region where the two overlap. All right, and yes, we end up shading the whole thing. However, we see 3 different colors. Part of the pink for the second set, and part of blue for the first set, but together, the part that becomes purple, that's the overlap, and that's actually the intersection where the two have elements in common, right? And well, let's look at another example. What is a, yes?
So going back to the last one,
Uh-huh.
in in order to answer that third one, you want to basically just shade the whole thing, or does the middle count?
Well, in this case, well, we shade the whole thing. However, since we're looking for A, intersection, B, the intersection is the overlap. Where these two sets overlap? Only at the purple region, where the two colors blend.
So like
Alright.
on a test though, like you still want us to shade the whole thing, or?
Oh yeah, the whole thing. So that's why I'm shading one set at a time. To have an idea of what it's going to look like when we put the two together. So sometimes you would just see them already all together, and then you think about, well, where did that come from? Well, it comes from doing this one first, and then second we do the other set, and then put them together, making a sandwich with it. All right? And I mean, highlighters work. So here, when I used to teach by the paper, I have my notes here, and you can see the purple actually standing out as opposed to this Samsung note, which is for some reason it's not blending the colors the way I want it. All right. Okay. Let's look at another example. For letter C, we start by shading the two sets A and C individually, and then we will put them together. So that's A, that's a C, and then A union with C. Then we'll see what happens in this case. All right, so let's see. A, which in this case is all the numbers greater than or equal to -4. That is, okay, bracket, and then to the left, to the right, I'm going to shade with blue. And then, what's the other one? C. In this case, it's all the numbers greater than 2. Careful, because this one will use parentheses, right? Not brackets, because it only has the greater than, not the greater than or equal. So that's going to be towards this side, towards the right. All right. So now let's put them together. All right. And we're going to look at the union, we're going to do that in a second. So number one, so let me put -4, draw identify, look at the -4 and -2. Okay, so for -4, and red for. All right. So here's the thing. This could be a little tricky because, well, these two sets have overlaps, right? So there's an overlapping region here where the two colors blend and the pink and the blue become less shade of a purple, some shade of purple. Now, but here we're not looking for the intersection like the one we did before. All right, we're looking again for the union. All right, we're looking for the union, and let's describe in words what we're going to do here. So, union, which is elements that are in A, C, or both. All right? So that is, well, if we look at this, so we're going to look at all this blue right here. It's by itself, and it's also in the intersection, and also the pink one. Well, the pink one has a smaller region, or it's a smaller set than that of the blue one. Nevertheless, what we're going to do, we're just going to, in a way, add up together. So this will be A union with C are going to be the elements that are in either or both. Well, it doesn't matter in this case if the elements in the pink region are not in the blue one. We consider all of them. Anyway, so that's just going to be between -4 and all the way to infinity. All right? So again, we just go with either one or both. So that's how we describe it. Bless you. Let's look at another example. Well, actually, the next example involves A and C again. Okay, involves both of them. So that's gonna let me go and write them down. So that's A, C, but in this case, we're not looking for A union C. We're looking for A intersection C. And in this case, well, so let's shade the set A. Set A, which is from -4 with a bracket all the way to positive infinity. I'm going to use same colors again. And set B in this case will be from 2 all the way to positive infinity. And well, let's draw the two together again. Let's make a sandwich of the two sets right here, right? And on the one hand, that's blue, all the blue one, and all the red one. All right? However, this time, we're not looking for the union. What are we looking for this time? In other words, I mean, from the colors here, what's our focus this time?
2 and above.
Hmm?
2 and
2 and above, right? If that's because that's where the two overlap, right? Where the pink and the blue become purple, in other words. So, whoops. This is where they overlap. All right, and in this case, that's what the intersection means, overlaps. So let's describe this as using interval notation, that is in A intersection C, that'll be, in this case, 2 to infinity. All right. So for A union with B. Okay, so this is A, this is B, this is A union with B. So that's going to be set A, which is from -4 to the right, and set B is from 1 parentheses and then to the left. All right, so that's going to be blue and red. Putting these two together, let me go back to 4, I mean -4, 1. Let me go back to shade, pink to the left, and blue to the right. Okay, so we just got the two sets together. However, this time we're looking for the union of the two sets. And what is the union of the two sets? How would we describe it this time? Yes? Okay, -4 to -1. Well, that's the part where they overlap, right? That would be the intersection, all right? This time we're looking for the union, not for the intersection. Corey?
negative infinity, positive infinity.
Negative infinity to positive infinity, do we agree with which is essentially the whole thing? Yet, well, that's because, well, we're looking for the elements that are in A, that is the part in blue, which is this whole thing, the elements that are in B, which is the whole thing in pink, or the ones that are in both, the intersection, well, pink, blue, or both, isn't that pretty much the whole thing? How do we describe the whole thing? Well, whoops. I know I forget to change these brushes here, so that's essentially negative infinity to positive infinity. All right? That's the whole thing. Set B, it's all the set of numbers that are less than 1. Right? That is from 1 and to the left. And then we have, what else? It's set C, which is 2, but then to the right. Putting these two together on the same number line, as we've been doing, okay, something interesting is going on here. All right, so that's going to be, whoops, like this and like that. All right, now we need to be very careful with the way we're going to write this result or to interpret the two sets together versus what they're asking us for. Now, they're asking us for intersection, right? In other words, the overlaps. But do these two overlap at all? No. Well, so how can we interpret this result? One way to resolve, okay, one way to interpret in words. No. Nothing, no. No. There's another word besides the no. Empty. So actually it's no solution, right? Because there's nothing overlapping. Okay, so this is how we are going to write the result. There's two ways to write it down. Okay, so B intersection C equals curly braces with nothing inside. That's an empty set, right? Or it's like an O or like a 0 with a diagonal cutting that symbol. This is a fancy symbol. Okay, let's write it down. Fancy symbol to denote empty space. And also curly braces with nothing inside also means empty space. Either way, so you can just write down the curly braces or the 0 with the diagonal. The incorrect way to write this down, check this out, don't combine them. So this one and like this, it's like being redundant, right? So it's either one or the other one, right? And both of them are correct options. For example, in the homework, most likely there will be an option. It's this kind of exercises, like the ones that I found in my math lab, by the way, are like multiple choice. You're given an inequality or rather a couple of inequalities, and then you choose the shadings as multiple choice. And if there's no solution, there's no overlap, well then you will choose the no solution option in there. All right, and let's see. So this is how we're going to work with with intervals, shading them, putting them together to determine where we have a union, where we have an intersection. It's important to describe domains and ranges of functions, like the stuff we have been doing before, like getting the domain and the range. However, when we get to finding domains and ranges for explicit functions, because pretty much every single function may have different restrictions, like, well, polynomials have no restrictions, rational functions, you don't want denominators to be 0, certain radical functions have restrictions. You cannot take the square root of a negative number, for example. Well, all those domains are described with intervals, with sets, and more graphically using these shadings. And when we put them together, what are we going to do? We are going to put these shades together to find the intersection. And that's going to be like the overall way to get the domain of a function. In the meantime, let's keep talking about inequalities. So now we're going to solve inequalities. And to get the solutions of these inequalities, we are going to rely on what we have been doing for this couple of pages of these handouts. All right, so let's see, solving compound inequalities involving or. So you will be given inequalities like pairs of inequalities. We need to pay special attention to the wording in between the two, whether we're looking for an or whether we're looking for an and. By the way, we are going to divide the types of inequalities in, well, these are the or inequalities, and there's also the and inequalities, but there's two types of and inequalities. And we need to be familiar with both. Why are we going back to solve compound inequalities? Because later, when we get to describe the domains and ranges of trigonometric functions like the graph, the wavy signs and cosines, and the other functions like cosecant and secant, well, we will describe this with these union symbols, with or symbols, and also we are going to be in the need of manipulating compound inequalities to determine the range of sine function and cosine function. Well, for that we're going to rely on what we're going to learn in this handout at the very end. You'll see what I'm talking about, and then later in the semester you'll see how this is going to come back. In the meantime, let's practice. Let's solve inequalities. And well, here I have the essential steps we follow in order to solve inequalities involving the or. Okay, so number one, solve each inequality separately. Well, the same way we did it here. See how we solve an inequality here? We're going to repeat the process there. And then find the union of the solutions sets of each inequality, as in example 2, as the one, like the ones we did here. You know how we have a union here, how we have a union there as well. So essentially this couple of examples right here were a prep for what we're going to do here to solve inequalities here, compound inequalities rather. And finally, express your final answer using both set notation and interval notation. By the way, when it came to the exercises we did in example number 2, I skipped the set builder notation. I just did the interval notation. Here we're going to do both, okay? So that, again, to keep practicing between the two notations. It's important to know both, because in some cases, on the homework, some question may be asking you for one notation or the other, okay? All right, so solve each compound inequality and graph the solution set. Also express your final answer using both set builder notation and interval notation. All right, so this is what we're going to do. Okay, let me draw a bar just to divide or just to separate the two inequalities, because we're going to do one process on one inequality and another process on the second inequality. So for the inequality 3x minus 5 less than negative 2, well, the way we're going to solve the inequality is exactly the same as if we were solving an equation, and it showed you the difference between the two. What changes, it's also the inequality sign and potentially some potential pitfall that I'm going to talk about when we get to one of those. Well, in the meantime, in this case, let's add 5 to both sides to cancel out this negative 5 with the 5. That's going to bring us down to 3x, and negative 2 plus 5 keep the same inequality symbol, and just write the result of subtracting 2 from 5. That's a 3. And then to get the x by itself, all we need is to divide both sides by 3. All right, so divide out the 3's, and that's going to be x less than 3 over 3, that's 1. X less than 1. So that's the result. So you can think of this as our set A that we're going to put together with our set B that we get from solving the second inequality. And let's go ahead and solve the second inequality, okay? So let's subtract 4 from both sides. That's going to cancel the 4 with the negative 4 and leave us with negative 5x less than or equal to negative 16 minus 4. Here that adds up to negative 20, right? Negative 20. Okay, here is the thing. I'm going to keep solving this inequality for x. So to get that x by itself, we need to divide both sides by negative 5. All right? And I'm going to make a mistake on purpose here to see if you can catch it. So that's going to be negative 5. Negative 5 on both sides. That's x less than or equal to 20 over 5. That's a 4. Negative over negative is positive. All right? And that's the result I think it is for this second inequality. Do we all agree with this result? No? Okay, Scott, you say no. Why not?
Flip it over when you change when the final answer becomes positive.
Okay, so okay, any other, okay, that's good to start with. Any other ideas as to why this is wrong? Are you raising? Okay, so you're raising your hand. Well, okay, here the mistake I did here. So every time we multiply both sides or divide by a negative number, we are supposed to reverse the direction of the inequality. So we need to reverse it like this. Right? Keep the equal still, however, just reverse the direction. Why is that? Well, this is just to provide a sense of to keep the logic sense of the statement. For example, let me give you a couple of examples. Okay, let me write them below because I need this space right here. Okay, do we agree? Do we agree that 3 equals to 3? I mean, that's a true statement, all right? Now, from the theory of equations, recall that whatever we do on one side, we have to do it on the other side as well. The idea behind it is that you can think of equations as scales, right? So if you put a kilogram on one side, then you have to put another kilogram on the other side to keep it balanced. So for example, this equation right here, I'm going to add 1 to both sides. And what do we get? Well, that's 4 equals to 4. And in this case, we still get a logical sentence, right? A true statement. I can also multiply both sides by 3, for example. That's 3 times 4 equals 12. And 4 times 3, it's also equal to 12. And I keep getting a true statement, all right? Now, what about inequalities? With the inequalities, we need to be a little bit careful because, well, check this out. Do we agree that 2 is less than 5? All right? Same thing. What if I add 3 to both sides? That's 5 less than 8. All right? And we still get a true statement. 5 is less than 8. Now, what if, can I multiply by a number? Well, let me multiply both sides by 2. All right? 2 times 5 equals to 10 and less than 8 times 2, which is 16. And again, we keep getting a logical sentence. It's still true that 10 is less than 16. However, what happens if I multiply by negative 1? I'm going to get negative 10 less than 16 times the negative 1, negative 16. Is negative 10 less than negative 16? So what do we need to do then in order to keep the integrity of the true statement? Flip, reverse the inequality symbol. Right? So we keep getting a logical sentence, a true statement. So that's the reason behind the changing the inequality direction every time we multiply or divide both sides by a negative number, right? Now, how about we repeat the process we did with the previous examples? Okay, let me draw a number line, another number line, and then a third number line. So this is set A. You can call this set A. This is set B. All right, let's put them together. What you might want to do here is put the 0 in the middle, just to have a reference, to have a sense, to have some number sense, by the way. All right, and well, it doesn't have to be exact. Just make sure your drawings here make sense, and that as far as number sense, and that you can read them and interpret them. So I'm gonna go to the number 1 for set A, and for the number 1. So because I see here an x less than 1, that means I'm going to shade to the left. All right? Shade to the left with blue. All right? And then for set B, I'm going to go to the number 4. That is 1, 2, 3, and 4. However, this time I'm going to use a bracket as opposed to parentheses like in set A. Because, and again, the difference is here we don't have the equal part, here we have the equal part, and those are represented by parentheses and then bracket. Question?
For A, why is it shaded to 0 on the other number?
That's, I don't know why. That's a good question. Thank you. Yep, my bad. And yeah, we were supposed to shade some from 1. Thank you. So, and let me use a different color for the second set B. Now let's put them together. And well, putting them together, we get this one, that one, shade, and shade. Okay, so what are we looking? Because we're solving an OR type of inequality, that's going to be represented by a union symbol. All right, a union symbol. A union B, rather. Okay, well, how do we know that A is an OR? Well, let's go back to the very first page, where we first defined these symbols here, the union symbol and the intersection symbol versus the keyword. So the word OR implies union. And how about we highlight those with a different color so they stand out when you go back to review this. So the word OR implies union, and the word AND implies intersection. All right? So whatever is in one, the other, or both, and the overlap for the AND. All right? Okay, coming back to the exercise. We're going to put these two together and find not the overlaps, but whatever is in one, the other one, the second one, or both together. And in this case, all we do is write solution set. That'll be using interval notation, the interval representing the x less than 1, that is negative infinity, to 1 with parentheses, and union with bracket 4 all the way to infinity. All right? So that's our solution set using interval notation. Now let's write this time. I'm going to write it using set notation, and it's not as hard as you may think, because set builder notations rely on writing in inequalities. And well, don't we have these inequalities already that we can just copy and paste in our curly braces? We're good to go here. So that's x such that simply list these two inequalities, x less than 1, comma, x greater than or equal to 4. Again, you may be asked for one notation or the other during in the homework. All right. So for letter B, for this inequality, 3x greater than or equal 7x plus 8 and or x less than 4x minus 9. Okay, I noticed some of you were moving the variables to the right. I think I see why you guys are doing that. That's because, well, you want to come up with smaller numbers, and somehow if you were thinking of subtracting the 7x on both sides, somehow I feel like you're afraid of working with negative numbers. Well, don't, because again, my advice here, every time you're working with inequalities, in the same way that you solve equations, make sure your variables end up on the left side of the equation and the constant values, all the numbers, on the right hand side. It's easier to interpret and read the inequalities and equations in that format. All right, so let's see. So what I'm going to do here is I'm going to subtract 7x on both sides. That's going to give me, okay, let's cancel the 7x's. That's a negative 4x, still greater than or equal to 8. Now, in order to get the x by itself, we are in the need of dividing both sides by negative 4. All right, divide both sides by negative 4. That cancels out the negative 4's here. However, 8 divided by negative 4, that's a negative 2. But in this case, since we are dividing both sides of the inequality by a negative number, we need to reverse the direction of the inequality. We keep the equal still. That doesn't change. That doesn't become greater than. No, it's just the opposite direction. All right? And that's going to be what we will call our first set A. All right? Let's call this set A. That will be plotted on the number line and shaded. All right, so let me split the two inequalities, and well, I'm going to need a space. All right, so x less than 4x minus 9. Again, you might want to have all the x's on the left side of the inequality and the constant values on the right. So what we're going to do here is to subtract 4x on both sides. That's going to get canceled, the 4x's. That's negative 3x less than negative 9. And again, in order to get the x by itself in this inequality, we're going to be in the need of dividing both sides by a negative number, which is nothing we've done before. I mean, we have done it with equations. But again, keep in mind that the effect here is to reverse the inequality symbol, and then negative 9 divided by negative 3, that's positive 3. And let's label this our set B. Okay? All right. Let's draw 3 sets, 3 number lines. Let's put the 0 in the very middle for reference to have a better number sense. Well, so let's call this set A, set B, and A union with B. All right? And what we're going to do here, well, let me plot set A, which is all the numbers that are less than or equal to negative 2. So let's see. So I'm going to go negative 1, negative 2 with a bracket, by the way, because it includes the equal part. It's less than or equal right here. And then in this case, well, we're going to shade towards the left because it's less than, right? On the other hand, I'm going to go to the number 3 for set B. That's going to be 1, 2, 3. But in this case, to the right, because of the inequality symbol, sort of gives us a sense of direction towards the right. we're going to shade towards the right, but in this case with parentheses. All right. Let's see. So I'm going to use a different color for this and shade all the way to the right. All right, let's put these two sets together. Let's make a sandwich of these two sets. So that's going to be -2, 3. Shade to the left, shade to the right. All right, but in this case, what are we looking for? Again, the key word here is or. All right, are we looking for the overlaps, or what are we looking for in this case? The union. Exactly. Okay, that's correct. So in this case, the elements that are in either A, B, or both, that is everything together. But of course, I mean, because there's nothing in between, that's where we're going to use a union symbol to indicate we're going to go like that. Now, here is where we need to translate, so to speak, these inequalities into intervals right here. And that's what we did yesterday, Tuesday. Change inequality notation into interval notation. All right. So, what we're going to do, this shading in blue indicate that we come from -infinity, and we're going to stop at -2. Close with a bracket, union symbol, and then open parentheses, continue from 3 and on. So that's our solution set. Using interval notation. Now let's write this using set builder notation. And again, usually that's more straightforward because, hey, we have those two baby inequalities here. All we do is just copy and paste those two inequalities and separate by commas. X such that x less than or equal to -2, comma, x greater than 3. All right? So that's our solution set here. This example, letter C, it's going to be a little bit more involved in terms of the algebra we need to do. We need to use the distributive property for multiplication. So distribute the 6 over the two terms inside of the parentheses. That's going to give us 6x minus 12 less than 12. Now keep solving the inequality. Add 12 to both sides. And that's going to be 6x less than 24. And then divide both sides by 6 to get x less than 4. All right, so that's going to be our first set, A. All right. We're going to do the same. Distributing the distributing property for the second inequality. This multiply the two terms inside the parentheses, x plus 3 by 4. That's going to give us a 4x plus 12 greater than 12. And then when we subtract both sides, the 12, well, that cancels actually the 12s on both sides, and that's going to end up being 4x greater than 0, and keep dividing both sides by 4 to get, in this case, x greater than 0 divided by 4, it's still 0. And in this case, that's going to be our set B. All right, that's our set B. What about it? Well, let's have a look at it. Well, let's put them all together. Let's put them together. And one number line for set A, one number line for set B, and one other number line for A union, because again we're still working on inequalities involving or. All right, we're gonna get with the and inequalities. And that's going to be, okay, so let's go ahead and do this. Oh, zeros for the very middle as a reference. And let's see. So the first inequality, x less than 4. I'm going to go to the number 4 roughly here. Doesn't have to be exactly the number, just as long as you get a good number sense and it makes sense according to the well-ordered principle to have the correct order of numbers. So that's going to be the number 4. Let me scale. And that's going to be, okay, since it's less than, we're going to go to the left. So think of an arrow pointing towards the left, and in this case it's parentheses only because it's less than. Had we had the equal, then we would have used bracket instead. So let's shade. Okay, let's shade using blue. And let's do the second set. The second set, that's x greater than 0. Well, 0 and to the right. All right. And we got pretty much everything we need. Now let's put them all together. That's going to be, okay, this one, that one. All right. Okay, this to the right and to the left. And well, in this case, we're looking for the union. And again, the union is going to be all the elements that are in A, B, or the intersection, or both of them, right? In this case, remember that exercise we did in the previous few pages in which pretty much added up to the whole thing? Well, that whole thing will be, solution set. That's simply going to be negative infinity to positive infinity. And using set builder notation, x such that x belongs to the set of all real numbers. All right? And these are some examples of solving inequalities that relate the OR statement, for which we look for the union of two sets. All right. Okay, what time is it? We'll have plenty of time. Okay, let's go to solving compound inequalities, but this time involving the word and this time. Again, let's recall that the word and means the intersection. All right? So this time we're going to find the intersection. We're going to find overlap. That is where whatever colors you use, where the two colors blend, that's what you're looking for. All right? All right. Let's see. So, and again, I have the steps listed in a similar way that we did for compound inequalities involving the OR this time. So, but in this case, it's going to be for the AND. And what are we going to do? Exactly the same thing for the first step. Solve each inequality separately, and then find the intersection of the solution sets of each inequality, and then put them together and look for the overlap. All right, and that's going to be our result. And again, using both interval notation and set builder notation. All right, let's see. So let's do one example. Let's solve the inequalities. 3x plus 2 greater than negative 7. All right, so let's actually subtract the 2 on both sides. And that's going to leave us with, well, that cancels the 2's here. And that's 3x greater than negative 7 minus 2. Careful in this case, that's negative 9. Now, the next step, divide both sides by 3. That's going to be x greater than negative 3. And that's going to be our first set. Okay, let's call it A. That's going to have its own number line. We're going to shade it accordingly with the inequality symbol and whether it's parentheses or bracket and the sense of direction. Let's do the same for the second inequality. Hopefully at this point you see the gist of this. It's the same process, solving inequalities, shading, but depending on the keyword, we are either going to look for a union or an intersection. Okay, let's keep working on this. Okay, so let's subtract 1 from both sides. That's going to be 4x less than or equal 9 minus 1, that's 8. And dividing both sides by 4, that equals to x less than or equal to 2. And let's call this set B. Right? And now we have all the information that we need to create these number lines, shade accordingly, put them together, and look for the overlap, look for that intersection. All right? So 3 number lines. 1 number line for A, 1 number line for B, and another 1 number line for A, this time intersection B. Why is this an intersection? That's because we're looking for an end this time. All right? Same idea, it's just how we're going to get the result this time. Okay, 0 in the middle again, just for reference. And well, letter A, x greater than -3. That means I'm going to go to the number -3, and we are going to go towards the right and via parentheses, because it's okay, let me get this first. So that's going to be -1, -2, -3 parentheses, and let's shade using blue. Of course, you can use the colors that work best for you. So here I'm getting a nice blending with these 2 colors, so I will stick to these ones. Okay, so I'm going to go this time to the number 2 for letter B. 1, 2, but in this case that less than or equal, well, this is in a way indicating an arrow towards the left, and the fact that we have the equal underneath the inequality symbol, that means we include the value, which is represented by a bracket. All right, now let's use that color. And well, it's going to be this one. All right, and what are we going to do now? The usual sandwich of sets right here. I'm going to put them together in the third number line that I have reserved for the 2 together. Okay, so that's going to be 1, 2, 3 parentheses, 1, 2 bracket. Now to the left with pink, and to the right with blue. And well, in this case, what are we looking for? We're looking for the intersection. In other words, where the 2 overlap, or color-wise, where the pink and blue become together a shade of purple. All right? And we have to, okay, let me write it down. So this is the intersection. Overlaps. Where it overlaps, all right? And well, let's describe that using interval notation. So let's write down the numbers to make it easy to see. So that's -3. That's a 2. So that's from -3, to 2. And then A intersection with B, that'll be -3 to 2, brackets for 2, parentheses for -3. And again, writing this using the set builder notation, well, curly braces, x such that -3, x, 2, just put them an x in between the two numbers, and put the corresponding inequality symbols. Well, in this case, if we have parentheses, that's going to be less than. We have brackets, less than or equal. All right? And that's the final answer for this exercise. All right. In this case, we're looking for the overlap, the intersection. All right.